All right, we are live. Welcome everybody to this next session of the Golden Path to Spring One. I am Cora Iberclyde. I'm a developer advocate at VMware, and it is my absolute pleasure to welcome Jonathan Schneider as today's special guest. How are you, Jonathan?
Doing well. Great to see you again, Cora.
Awesome. Yeah, you too. You too. Where are you joining us from?
I'm joining from effectively a closet inside the Microsoft office in Toronto right
Oh,
now, but really
cool.
great venue.
Looks like a nice closet. I've been to the Microsoft office here in New York City, and they have beautiful offices. So I hope that it's at least a comfortable closet.
It is. It is.
Yeah, I'm really thrilled to see you. So I'll I guess welcome everybody. Also, we're here. I'm going to keep an eye on the comments. So yeah, let us know. Hello, Shankar. We let us know where you're joining from, and as we go through today's session, feel free to ask any questions during the session, and I will try to politely sneak in and interrupt Jonathan so that he can answer your question as quickly as possible. So I guess I'm really thrilled to host today because I personally know John, and we initially met working together at Pivotal. You had previously worked at Netflix, and then
Yes.
you've gone on and done something really amazing and created a really a fascinating, I think, startup. So I just want to give you a chance to, in your own words, tell people a little bit about who you are and your background, what you're working on.
Absolutely. Yeah. So I'm Jonathan, and these days I'm working on automatic code remediation at massive scale. I really started technology and working in software because it was such a creative discipline, and these like migration type activities are not super creative. So I want to take away that toil. But when we worked together previously, it founded Micrometer project there and the Spring team, Netflix engineering tools before that.
Amazing. A lot of very, very impactful tools.
Thank you.
Yeah.
Yeah. A
Yeah.
lot of assistance from the community in every case. Yeah.
Yeah. That's it is amazing to see the collaboration and that. But I think the collaboration from the community goes hand in hand with like there's a certain receptiveness, right, on the development team, and that it's a really beautiful
Yeah.
sort of synchronous. Yeah. Cool. So, so you're here to talk to us specifically about automating the refactoring of your Spring applications
Yes.
using this open source project called OpenRewrite, right? Which I guess
Yes.
you'll probably go into a little bit of the history of it in your talk, right? But something you've been working with for quite a long time.
That's right. Yeah. Off and on, but more on than off lately, I would say the last couple of years.
Awesome. Okay, so let me, I'll hand the stage over to you. What I'm going to do is, and yeah, so just keep your comments coming, everybody in chat. And I will share your screens, Jonathan, and then I'm going to remove myself from the screen. I'll give you a 3, 2, 1 countdown, and you can start your presentation.
Okay.
All right, here we go.
Very good.
So
Thank you, Cora.
you're welcome. All right, ready in 3, 2, 1.
Action. So hello, here to talk, like we said, about automatic code remediation today, which is going to take a little bit of acclimation. I mean, and there's some context, I think, about what we're even talking about here. To begin with, trying to start at a really high level, I feel like the software industrial revolution has long since arrived. And what I mean by that is the growth and the availability of just all sorts of amazing open source technologies and third party components have made the act of building software a much more it's much quicker to assemble customer experiences out of third party components that we find. And so it's like a similar transition that software development has gone through as has happened in many industries. The problem is, I think that once we produce that component, once we create another app, let's say we use start.spring.io, we fire up a new app, we add some API endpoints, we get it to production very quickly using some amazing platforms. What happens then? The application tends to sit on the shelf, and every new experience that we write implies some degree of maintenance related activity as well, right? We have to keep these applications up to date. both because the components upon which we're building are changing out from under us, and because on a constant basis, we're discovering new vulnerabilities and new problems with code that we thought was green yesterday. So we've seen this growth in software on the shelf, in a variety of different industries, a variety of different sizes. The smallest company I work with today had about 70 developers 10 years ago and 40 repositories of source code. Today they have still 70 engineers because they're hiring out of a specific place, and 1,200 repositories. So this is the kind of growth that we're seeing all over the place. With that growth in the number of repositories also comes a growth in complexity, right? Microservices and API-driven software, there's a lot of interconnecting components. Obviously, a lot, 80% of a modern application is third-party now. This implies a larger attack surface area for exploits. And so, given the current state, what are we to do? How can we innovate going forward, adding new customer experiences when the toil of the maintenance effort on the back end is, kind of growing and threatens to overwhelm our team's productivity? This is the dilemma that I started feeling about 8 years ago at Netflix. Was working on engineering tools. And we had some big initiatives at the time. There was a Java 6 to 7 initiative, a Java 7 to 8 initiative. We were trying to change internal frameworks, thinking about vulnerability patching and how we could do that in a more efficient way. And interestingly, there was a freedom and responsibility culture. So if I was working on engineering tools, I couldn't impose any constraints on what product engineers did. We had to build experiences that engineers would opt into rather than putting a gate in front of them and forcing them to accept a change or to do something by a certain date, which is really a beautiful culture. I mean, it leads to solutions that are most ergonomic to the end user all the time. Really forces you to think in a servant-oriented way, especially if you're on a central team. But when faced with this problem of massive change that we were trying to affect, I started in the same place that I think the industry has. It was reporting. It was identify problems, scan for things, report them as far left in the software delivery lifecycle as possible, put it in front of the developer in CI, put it in front of a developer in IDE, put posters up on the wall, this kind of thing. But was finding that it just wasn't really yielding any action. Developers would just, not act. It didn't seem to matter what level of, sophistication we gave them in reporting. And so if you're going around asking, what could I do to make you move along with me on this journey, they would say, sort of sarcastically, do it for me, or else, I've got other things to do. And so I think you hear that enough times that you start to think, what would it mean? What would it look like if we were actually to make that change for the developer? And because of the same, so we start thinking source to source transformation. How can I modify the source code? How can I write code that will rewrite other code in a way that does the work for them? But because of that same freedom and responsibility culture, there was no stylistic consistency to the code base. We weren't all using the same dependencies. We weren't even all using the same frameworks. And so the challenge seemed very, very difficult. The foundational assumptions that we had to make in trying to do source to source transformation was such that if we're going to suggest a change, it needs to look idiomatically consistent in the context of each repository that the change is being inserted into. And out of this pressure cooker of, is really is where OpenRewrite emerged as a refactoring technology. And we're going to get into a little bit more about this. I would love to show you here what it looks like actually to develop recipes and perform transformations. And there's all sorts of different interesting directions we can take the conversation with a little bit later. But at its core, what OpenRewrite is it's a source-to-source transformation engine. So the text of the code, all the changes that you need to make happen, and it does that by doing abstract syntax tree manipulation. So that's, if you kind of rewind all the way back to your compilers course in college, you know that a compiler will take the text of code, it will parse it and analyze it and turn it into an abstract syntax tree. And then there's another phase of the compiler that walks back over that AST and tries to discover, for this method call that I saw, where was it declared? Where, which library did it come from? That's what's called type attribution. It goes and adds type information to the tree. And then from that enriched representation, the compiler will generate bytecode that we actually run. And of course, we're talking about Java here, but it works similarly for a lot of other languages. We call that, that type attributed tree doesn't really have a name. If we're going to make tree manipulations like this, what we want to be able to do is get the text of the code to the tree, modify the tree a little bit, and then print the tree back out to code in a way that faithfully preserves the style of the original code. And I mean, by style, I mean like the white spacing. Does it use tabs or spaces? What does its import for ordering look like? These sort of things, where it's comments. And much of this information is discarded by the compiler in advance of it creating that type attributed AST. So what OpenRewrite is operating on is the AST plus all the type attribution information, plus we go back and grab all the formatting from the original code and put it on the tree as well. And the combination of those three things we call the lossless semantic tree. This is the sort of foundational data structure that we're going to build on. That's kind of a lot. So I think let's kind of go up from theory here a little bit and look at a specific example of a kind of transformation that we typically have to go through. Then I want to show you how we can kind of do it at scale. And then I want to show you how we would actually write a new recipe to perform a new transformation.
I just wanted to, Jonathan, because this stuff it's so fascinating, but I just wanted you to maybe just repeat that just in case, because it's a lot to take in.
It is, yeah.
Last three bits that when you summarized it and you said, these are the three pieces we have that we call the lossless semantic tree.
Yes.
Go over that again.
Yeah, so the blue that you see here is the syntax. So I would see a syntax element like a literal or a variable or a method declaration or a class declaration. Those are syntax nodes. And then the second thing is type attribution. So when I see a method invocation, I see something called println. Which println do I mean? Is it the one that comes from output stream? Is it one that comes from another type? And so trying to locate that method that's making that where it's actually defined. And then the third thing is the formatting of the code, because usually a compiler will discard all the white space of the original text of the code as it's parsing it into that AST. So it's something the compiler doesn't really need. I don't care if you use tabs or spaces; it doesn't impact how the program actually runs. So we have to go back and bolt that on there as well. So those three things.
Gotcha. All right. Thank you.
So I'm going to stop this screen for a moment and share a different one. In this different one, we're going to go into, let's see, make sure I get the right one here. I think that we see the right one now. So let's look at a specific change, and we're going to look at JUnit 4 to 5. So I choose this example all the time because JUnit 4 to 5 is something we're supposed to write unit tests for our code. These unit tests are non-production code, interestingly, but also if you're now going to migrate from, say, Spring Boot 2 to Spring Boot 3, you have to move from JUnit 4 to JUnit 5. And the changes are they look very cosmetic in many ways. There are some really significant improvements in JUnit 5, but a lot of the changes are very mechanical, very cosmetic looking. And yet they're very hard to do with a regular find and replace expression or find and replace operation. So as an example, this is a PR that OpenRewrite generated for the JUnit 4 to 5 migration. And you can see that, we changed org JUnit before to org JUnit Jupyter API before each. So just change the name, change the package. We removed this class runner altogether. So we have to go locate all of those and remove them. And some of the changes are more structural. So you used to be able to define an exception on the test annotation. At this point, you're supposed to use assert throws and put the exception down here. And to preserve the same behavior, we would have to take the method body here and put it into a lambda. This example right here demonstrates the idea of crafting the change or massaging it to look idiomatically consistent in the context of this repository. We can detect that this repository uses tabs. Therefore, I'll use tabs when I'm adding this new block. I'm looking at the import ordering format. Does this project use wildcard imports? How many types in a package go into a wildcard if I am? How are the blocks of the imports organized? So all of these sort of things that seem trivial, but are really important to us as developers to preserve a consistent style in our projects and makes it more readable, and it's more enjoyable. And so a recipe should make changes in a way that preserves that. And the thing about JUnit 4 to 5 is that you've seen a few of these kinds of things. I would have to go through every unit test that I ever wrote and make the same kinds of changes over and over and over and over again. And if, like in many places, I'm doing I'm writing using a microservices architecture, or I have just a lot of products on, that my team is responsible for, I'm making this kind of change in not just one repository, but tens or hundreds of repositories. And you see how this is just kind of soul-sucking work that we don't really want to do. And that is exactly the kind of thing that we're really about changing. Another component of Spring Boot 3 was to move to Java 17. To move to Java 17, you had to move to Java 11. To move to Java 11, you had to deal with the Jigsaw introduction in Java 9. So Java exit Jakarta was a thing. You had to add dependencies, change build files. There's just a lot of work to do there, depending on the kind of API surface area that you used. So we've seen this PR here on one repository. I think where we're continuing to work on tooling is around how to take that recipe. And again, we'll show you what a recipe looks like here in a moment, but how to take that recipe, which can be applied using Maven or Gradle plugins on an individual repository, and how do I apply that across thousands of repositories and hundreds of millions of lines of code to affect a change across the entire enterprise. And so I want to give you another sense of where I think the world is really going increasingly. We're going to look at this marketplace. We're running this service called Modern publicly and ingest about 300 million lines of open source code every night. And here is what we call a marketplace of OpenRewrite recipes, which themselves are all Apache licensed. And we're going to just kind of click through into one of these, go into common static analysis issues, and be able to run this recipe, not just on one repository, but in this case, we're going to run it on 146 repositories. And these repositories, what I mean by this is the form that is the lossless semantic tree, that really dense tree representation. That's what these recipes are going to run on. So this common static analysis issues recipe is actually one that is a little bit different than the migration thing we were talking about. It's about doing static analysis and SAS scanning tools, SAS tools like SonarQube will typically just report issues and leave it for the developer to fix. We've been, and the community has been, writing recipes that not just identify those things, but fix them for you. So you see this common static analysis issues consists of a series of recipes that themselves our individual units of transformation, and we point to the RSpec issue originally. But let's get this thing running. If we just run this on these 146 repositories, we're gonna, we're kind of operating very quickly on a lot of code. If I were to click into one of these things, you would see the change that was made. I could say, why did this change? Well, I'm doing null avoidance, fixing missing braces, removing unnecessary parentheses, these sort of things. And ultimately, what we're trying to get developers to be able to do is to say, select all here and commit directly to all 41 repositories here at the same time, or to create a PR for all 41 at the same time, or whatever it may be. And the promise is that the estimated time savings, if I had done this manually, it'd be 157 hours at this point, still running, and this is 198 hours, and this is just work that I don't want to do, and that realistically we just aren't getting done. So this one's very flat. It's just looking for individual sort of code quality issues. But when we think about something like Spring Boot 3, to migrate to Spring Boot 3 involves first migrating to Java 17, like we said, which it also involves migrating to Java 11, which has a bunch of other steps. To get to Spring Boot 3, you first have to get to 2.7, which means you have to get to 2.6, which means you have to get to 2.5, which means you have to get to 2.4, which means you have to do JUnit 4 to 5 migration, which means you have to do Mockito 1 to 3 migration. So you can see these things get very, very deep very quickly. And I think that's the nature of our ecosystem. So it's very important to me that OpenRewrite is a Apache license standard for writing recipes, and that we're over time able to change the responsibility back to the framework author. If you make a breaking change in a library and you have a lot of downstream consumers, you owe them a recipe that helps them move forward with you to the newest version. So kind of the mantra of if you break it, you fix it. I think that's the moment when I think we're all actually able to innovate a lot faster, because you're not as afraid of making breaking changes, because you can provide the automation that can then that can get the work done more quickly without really impacting your users downstream. That's what gets really exciting to me about this thing, and its possibilities.
So Jonathan, just to clarify what you're saying, you're talking, of course, of something technical, but you're also talking about sort of a cultural shift.
Absolutely.
That you're trying to promote.
Yes.
Mm-hmm. Do you see that?
Absolutely.
Do you see that? Like how I guess how is that going? How do you see that cultural shift moving with the adoption and the receptiveness?
I think we're starting to see some really good signs that this is going to catch on. We have the Spring team, Alex Boyko and Andy Clement's team working on recipes. We see the Quarkus team at Red Hat, the Open Liberty team at IBM, the Axon framework authors writing recipes, Mockito authors, the JUnit authors, the Micronaut authors. So what I think we need to do is, it's of course easiest to write recipes at the lowest level. Mockito, there's fewer changes there. Spring has such a wide ecosystem and casts a wide net beyond just its own libraries to these things, that it includes that the more that we get lower level library authors writing recipes, the easier it is for the Spring team to provide recipes, and the easier it is for all of us to move forward.
Right.
But I'm encouraged because I think that there's really not another choice. I think at this point we're seeing such a volume of code in especially in the enterprise, that manual work has just become
We're creating a monster.
We're creating a monster.
Right.
And I think we're actually past this tipping point where it really became unmanageable. I don't know when that happened. I think it was in the last 3 or 4 years. And so what we have is now like applications that are probably, kind of 3 or 4 years behind where they should be. Mm-hmm. And, the problem is kind of, growing. When we think about trends in general, there's a lot of talk about generative AI, especially in writing new code. I use Copilot every day, and it really advances my productivity. But what does it help me do? It's an authorship experience. It helps me write code even more quickly, which actually implies a greater degree of maintenance. And honestly, start.spring.io was another example of a step function increase in productivity. Moving from when we had to run WebSphere on our local machines and it took 45 minutes to start, to Tomcat where it took 45 seconds to start. That was a step function increase in productivity. And so, all of these things have kind of conspired and inspired over the last 20 years to make us more efficient at writing a lot of this stuff.
Right. You're getting a lot of positive feedback, a lot of goods and thank yous. And one comment here, somebody's
They did.
Spring STS team integrated. Cool.
Yeah.
IDE
integration, I think, is important. I'm glad they did that work. I always, with a limited amount of time, I'm always thinking about how to solve a problem horizontally across 1,000 repos. But then that same recipe that helps horizontally across a lot of repos, you also want to kind of bring to the local developer experience to solve it as early as possible as well. I think that's the general trend of all good developer tooling, that you meet developers anywhere and everywhere that they are, in the IDE, in CI, on the side.
I think it's really interesting what you said earlier also about really respecting the style, because there's some things that, you could say these are maybe better practices stylistically, even for readability or maintainability, but then there's other things that are really personal choice or team choice, and you want to respect that as much as possible. And it's kind of going that extra mile, right, to make sure that your automatic refactoring respects stylistically what's there.
That's right. I think of it as, and I hope this analogy isn't too crude, but it's like a refactoring operation is like a transplant that we're trying to, or a fix is like a transplant that we're putting in somebody else's body of code, and if that body doesn't recognize that transplant as its own, it gets rejected. For good reasons and bad reasons. I mean, at some point, do the braces really matter? But they do. It's a personal choice. And so if our goal, especially that, again, I go back to that experience of having to try to be a very servant-oriented developer tooling person. If our goal is to accomplish some change across the organization, then the best way I can do that is by making it as easy as possible for people to accept the change, which makes it look like.
Absolutely. Yeah. All right. I'm going to hop off screen and let you continue with your presentation.
No, I'm really glad you interrupted. So, or joined, I guess the conversation is like super helpful. So,
awesome. Okay, I'll come back if we have more questions, or unless you want, unless you want me to stick around, but otherwise I'll come back as soon as, all right.
Very good. So if we were to look at one of these recipes, this one, recipes think of it as a rule-based system. And we could talk about AI here in a little bit as well and its application to this, but a rule-based system that is building around encapsulation. So just like in object-oriented languages, we're encapsulating behavior at a higher and higher level, here too, transformations are encapsulated at higher and higher orders, units of functionality. So there's the operation of changing a method name that can then be used every time I have an API change that involves a method name change. There's, that's sort of like a base building block then we build upon to do higher and more complex things. There's upgrading dependency versions in POMs and Gradle files. That's a building block that's reused again and again. And so some recipes, like this is a composite recipe that is a transformation, but it's composed of a lot of smaller pieces. And in many cases, these big compositional recipes, we can actually define declaratively in this like YAML sort of format, where we're really just specifying a recipe list of other things that together go into what it means to do unified best practices, for example. But at the fundamental level, every recipe is really a program. And so a program is, I thought this one would be one, and it isn't. A change type is certainly a program. It's a class. It's a Java class that extends recipe. and it implements the visitor pattern for, modifying the tree. So let's very quickly, actually, I think we have enough time to just write one of these recipes, very simple one, so you get a sense of what that feels like.
So as you're pulling that up, let me just share a question here.
Yes.
This is about the upgrade path. So Ramaduna says, so if I get it, we cannot migrate from Spring Boot 3 XX from 2.7.5. We should apply a recipe to get from, go through the 2.7.6, 2.7.7, and then go to 3. Is that?
So recipes themselves can chain other recipes, and that's what. So the Spring Boot 3 recipe chains a recipe that moves you to Spring Boot 2.7, which in turn chains a 2.6, which in turn 2.5, 2.4, 2.3. And so you could take a set of, say, 100 repos, some of which are on 2.3, some of which are on 2.5, some of which are on 2.7, and it's going to go through the incremental steps needed to get you to where your intended destination may be. And
that you don't have to do it.
That's right. And each one of those recipes, the migration to 2.7 is itself one that you can run independently. So, we're not opinionated here. You could just take the Spring Boot 2.7 recipe and say, like, can we all just get to the latest 2x version first? And then we from there leap forward to 3. That's fine. I think that's totally reasonable. And there's reasons people do that. But, think of them in that way, that they're just chaining incrementally one step to the next.
Cool. Okay, should I share your screen, the new one you have?
Sure, yeah. I'm always switching screens, just like pulling things in and out. So, just go to, this is the wrong one, I think, actually. Let's see, what are we seeing?
All right, so let's
migrate Java, right? Yep, that's great.
Is that right?
That's
so take that out and then.
Yeah, no, migrate Java is the one I want. So
that is
I think we've got the right screen.
Okay, cool. There you go.
Yeah. So we're going to write a recipe just like, use literal 42, something like that. And extend recipe, kind of like I mentioned before. I'm going to actually create the test real quick as well so that we can hide this little thing. Use literal 42 test, implements rewrite test. And let me hide this thing over here so we have a little bit more room. So first we've just got a class, and a class is recipe. It has a display name, always use 42. It has a description because, see, Copilot, right? 42 is the answer to life, the universe, and everything. That was great. It's an authorship experience, right? It's helping me write. I'm going to implement the visitor pattern here. So I'm going to use the visitor pattern. You can think of as like an event-driven system for making changes to a piece of code. So I'm saying I want to change literals. So I don't need to worry about where a literal occurs. Does it occur in a class or in a method or what? I just need to implement visit literal so that I have a chance to intercept every literal that I see. And again, see, Copilot's helping me write these, but not quite doing the right thing. If it's an instance of integer, and maybe if and that's kind of close is not equal to 42, then I would make this change that would say, change the value of the literal to 42. And that is the mutation that I'm making. So looking at the test, I could say, I'm going to specify that this test is all about testing this recipe that we're just working on here. And I could say, use 42. And I can specify that I'm wanting to test a change to Java file. I'm going to do a little trick here that's really kind of cool to know. You can use these in IntelliJ. You can use these little comments like this: language equals Java, not 42. And the IDE will actually, at some point, syntax highlight. See how it syntax highlights the text of the string. So the testing framework allows us to build little code snippets like this that exhibit some behavior. Like I want to say, suppose I start with 30. I want to make this 40, let's make it 41 first so that it fails. And I could run this test here. And it should fail, and it did. And a really cool trick, if you don't know, is whenever an expectation fails in IntelliJ, if you are not using the Gradle integration, but using the IntelliJ runner, you can hit this view assert equals difference or hit Command D, and it'll actually bring up a side-by-side comparison of the real and expected values. And you could see, yeah, I got 42 instead of 41. That's simply because I wrote the test wrong. I make this change, and it's 42 afterwards. And then this recipe then use literal 42, if this was something that was actually something I really wanted to do, now becomes a building block that I can incorporate into a framework, a wider framework update. But we really, that's what it means to encapsulate a very specific change. Recipe writing itself there's a lot of different options and a lot of different types of operations that we can do. I'd say it's best described over on docs.openrewrite.org, where we have a lot of examples. And just going through the catalog and looking at recipes really shows how to do it as well. I'm going to share one other screen because I do want you to compare this. This is very much a rule-based system. I wrote a program, it has a deterministic output, and because there's so much talk about generative AI at this point, I want to show you what it looks like to do a similar thing with a generative AI. And for that, I'm going to share a different screen. So we've got rewrite generative AI here, I think, yes. We've started folding in prompt-based editing to OpenRewrite itself so that it's an option that you can use. And for this example, let's think about an operation. This is a stylistic thing where we're saying the default case in a switch statement really should be last. Not really for functional reasons, but just for stylistic reasons. And so we've got this test, default case comes last test, and we're going to have implemented this with a prompt instead of like a natural language prompt, instead of a manipulation of the ASTR itself. And what we would expect to see is that the default case has been moved to the last position here. So what I think is that there's a relationship between this visitor pattern and using these prompts. And so I've implemented visit switch. I've looked for some very basic like potential edit site, which is a switch statement that has a default case. And I've said, given this, I've used this generative code editor, which is part of OpenRewrite now, and said, given a switch statement, rewrite the switch statement where the default case comes after every other case. And interestingly, if I run this test 10 times, what we find is that it succeeds like 7 out of 10 times, which is a bit surprising, right? Because after all, it's the same input every time, and it's the same prompt every time. And so something to really like try to internalize is that these language models are probabilistic data structures. They're not stable over time, and so they will do things that are different than you expect from time to time. And if I think about why, like when it didn't do the right thing, what did it do? And we find that it does things like this. It'll move the default case last, but it'll also move this one up. I didn't ask it to do that. And so the act of trying to improve accuracy on this is kind of like talking to a child, like that's trying to, circumvent your will. It's like, rewrite this switch statement where the default case comes last, but don't reorder any other case statements. Don't change the labels on any other case statements. Don't introduce blocks where there aren't any blocks. Don't go to your friend's house on the way home from school. Like this kind of try to enumerate all the possible things it's going to do and list them all. And even still, we find it to be like 8.5 or 9 times out of 10, right? So I think this is a really interesting tool. I think it's interesting to have as part of an automated refactoring engine. It's a tool that's really useful because it's easy to write the recipe. But what you're doing is you're trading off recipe time, authorship time, for review time on the back end, because you can never totally trust the outcome there. And if I'm trying to run this recipe on 500 million lines of code and commit it to thousands of repositories, I want to be able to trust the outcome. So it's a really interesting tool to have in the toolbox. I think these systems, rule-based and generative AI, like so many technology choices, are better together and use the right tool at the right time than they are apart. And I'd love this to just kind of be more open discussion at this point. So happy to kind of stop there and go where you'd like.
That's fascinating. So basically that last thing you were talking about, that generative stuff, that's what's used in the Copilot thing. So where the expectation is that as a developer, for every suggestion, you're going to apply judgment and say yes or no.
You could see it as I was writing the recipe, how it wrote that initial if statement for me, which was right. But then it didn't have the second condition I was looking for. And so it even completed a condition. The condition wasn't quite right. I did a lot less typing in the end.
Right.
And I think that's great. And so when people say, Copilot writes 30% of my code, it's kind of true, and not true at the same time. It's like it's a buddy. I think the word Copilot is really a great name for that. It's an assistant.
It's almost like you're pair programming with somebody, and
you're
describing and they're suggesting.
It is. Absolutely.
And I guess
I think of them as authorship experiences. Single point, my cursor's blinking here, you're suggesting ahead. And it's pre-production code, it's pre-shipping it. What really, I think OpenRewrite's about is post-production, multi-point, massive change. And those are very different, I think, things ultimately.
And with the generative, you're also, the review is happening in the moment, because there's something about in the right time, right? So you're reviewing as you're doing it. You don't have to go back and say, this was applied on this code, then go review it. Although I guess even then, though, the OpenRewrite stuff would be a pull request, right?
It's a pull request, yeah. Yeah, so people tend to go along this maturation curve because, even that concept of just like, I'm just going to just commit this across 100 repos at the same time, it's a bit scary.
Yeah.
So you tend to do something simple at first, run a very easy to review, like, okay, I'm just going to use the diamond operator correctly. And then, just commit that and you feel better, like the next time you look at that code, it's going to look a little bit better. But then, well, maybe JUnit 4 to 5 isn't so bad because, after all, it's test code. If the tests don't pass, then I'm not going to harm anything in production, but it saves me a lot of time. And then you think, well, maybe I'll take minor framework version updates, maybe not major yet. And then you just kind of like move your way along this maturation curve.
Right.
I think that's fair.
And separate your Git commits into things you can sort of, accept one at a time, one and not the other. It's not all or nothing.
It's not all or nothing. Mm-hmm. And even if you do it wrong, it's like git revert, right? It's not like you manually crafted this change. So it's easy to.
Is that concept built into it, like where each set of things has its own Git commit is that the default mode?
It is, yes, absolutely. So, well, you mean in like a one of those really deep composite recipes?
Yeah.
Those we will pile into one commit. But you could be staring down Spring Boot 3 and saying, like, I know that involves Java 17, I know it involves this and that, and you could just run the Java 17 recipe alone, commit the result, so it isn't an isolated commit, then run the whole thing again. It's not going to make any changes for Java 17 because you already have.
Right.
And then everything else gets in a second one. So I do think you can kind of go as fine or coarse-grained as you want on those sort of things.
Cool. You're getting like thanks and positive comments. If anybody has a question, definitely pop it in. If anybody's tried to use OpenRewrite, tried to either write recipes or apply it on your code, and you have any comments or feedback, or want to share anything, please go ahead and feel free to do that in chat. There was a question about earlier. someone who's familiar with your startup, which is related, of course, if there's a way to try it out, I guess.
Certainly the easiest thing probably, I mean, I don't know how well this scales forever, but just contact me directly. And I'll put you in touch with the right person. But it doesn't take a lot of time. Usually takes about 2 hours to set it up with somebody, somebody new and connected to internal repos, and working with some really large organizations that have a lot of sensitivity around their intellectual property. So we've kind of been through the ringer on security before. But yeah, I think it's an interesting thing to start thinking about, especially if you're doing any scanning or security, reporting. Start thinking about how can we make this more actionable.
Mhm. Mark McKelvey is asking how far along the dependency management for Gradle is coming.
Yeah, we've got some basic dependency management for Gradle Groovy right now. The Kotlin main support, parser, was just added recently. And we have a little bit of work to do KTS type Kotlin parsing as well. This is it's an interesting thing to reach out and ping Sam Schneider, who's really working on Gradle dependency management right now and knows all the details of that. We have a Slack that you can get to at the top of docs at openrewrite.org, which you can jump in and just ask Sam directly. But it's a complicated topic, right? Dependency management was hard for Maven. It's harder for Gradle, but it's something that's possible.
So you said
there's an interesting. Yes.
Top of OpenRewrite docs. There's a link to a Slack where you can find Sam Schneider. Yeah. Okay, sorry. Yeah, what were you going to say?
Yeah, it's one of the interesting side effects or related questions on Gradle is that what other languages are we supporting or are attempting to support? And so did start in Java, then started adding infrastructure as code. So Terraform, auto remediation, YAML, JSON properties, even just the Spring Boot 3 migration involves YAML and properties changes. And so obviously Kubernetes manifest remediation is a key part of that, GitHub Actions, these sort of things. We say around infrastructure as code, it's like copy, paste, drift to a point. You kind of take the same YAML block and you copy it a bunch of different places. Then something changes and you got to go back to all those, places and change it. It's been good in the sense that it's obvious when you look at the repo what's happening. It's bad in the sense of the copy, paste, drift thing. And so being able to have both, like the benefit without the downside is really cool, I think.
Yeah, for sure.
As we started thinking about other languages, one of the big surprising things we learned is that we started looking at TypeScript and its AST model, its LST model is the same as Java's. It just doesn't look like it when you're looking at the text of the code. The way it's printed back out to text is different, but the fundamental model is the same. Python, Java, Groovy, Kotlin, C# all sit on what we call a grammar island of self-similar languages that they actually share the same model for the most part. So some of the base recipes we wrote, like change method name, that we wrote for Java, just automatically work on Python, automatically work on TypeScript, was a really super surprising result. And that works inside the JVM too. So that JUnit 4 to 5 recipe should work on Groovy, work on Kotlin, without having to write that recipe 3 different times. That said, there's a limit to that island. And so we wrote COBOL integration last year. That's on its own island.
Wow.
Not near anything else. YAML's obviously on its own island. So it's, there's some reuse coming and but to a limit.
Wow. Amazing. Mark says, thank you. I'm looking forward to it. Thank you.
Thanks, Mark.
That's fascinating. Anybody else? If you have questions, try to get them in. So what, how long are you going to be in Toronto?
Not here for very long, just until Saturday. So just meeting some folks while I'm here, and moved to Miami not too long ago, like about a year ago, where it's super warm. And so
were you there for the horrible rains? Was it a week or two ago that cars were like 4 feet in water?
Yeah, I didn't really notice it. That unfortunately happened to Fort Lauderdale, and which is just north of Miami, and it did rain quite a bit in Miami, but it seems like Miami itself has a really
Okay.
well built-in pumping and drainage system now, such that it doesn't really flood the same way.
Wow. Yeah, that was wild. My
Yeah,
parents are down there, and I have some friends down there, and they were sending pictures, and literally cars were, yeah, up to
just
the window in water.
disappearing.
Yeah. It was,
Yeah,
yeah.
yeah, it's terrible.
Um, yeah, I don't see more questions coming in, but I see, yeah. So we were, as we know, we're streaming to a few different channels here. So I don't know that everybody sees all of the feedback, but you're definitely getting thank yous and positive comments. So,
Mm.
um, and I want to thank you. I think it's fascinating. I think you're coming back. Are you going to be joining us again later on, down the line for Golden Path?
Yeah, I think either me. I think there was a talk that was more around AI, if I remember correctly, and
Mhm.
the AI applications. And I hope we have a new um, person working with us, Justine Gehring from McGill University. She's a PhD in AI for code, and it's just super fascinating. Like, just come with all your questions about where's the cutting edge and where are the limits, and always find her really good at explaining very complex topics in a way that's approachable.
Awesome.
So I hope that she's able to do that one.
Of course, yeah. Cool. I mean,
Yeah.
I feel like as anybody who's played with Chat GPT in the last few months, the whole AI thing has just, gone to a whole new level. It's so
It
crazy.
has, hasn't it? Where do you see applications? Have you started folding it into any of the things that you do for your work?
Personally, yeah. I mean, yeah, not from a, yeah, from a writing perspective and from a research perspective for sure. Yeah,
Right.
both work and even just sort of, instead of Google, sometimes it's just a bit easier. But definitely, like, yeah, it helps for editing and writing and researching. And I think
Yeah.
I still keep eyes open, and I say, like, is this really right? Do I need to double check it? But
Yeah.
I'll give you, like, yeah, it's why I was trying to impress upon my parents, like, the impact. And I remember with my mom, we were looking up some historical incident, and I said, okay, well, just to show her what it does, tell me this story of this historical incident for a fifth grader, and then tell it to me in passive voice with an academic tone. And then I said, give it to
Mm,
me in the Shakespeare sonnet. And I was reading this Shakespeare sonnet appears in 2 seconds flat. And I was reading it to her, and it's just this, piece of history, but I literally wanted to cry at different, like, it was so good. It was so emotional. It's just
hmm.
mind boggling. So
It
yeah,
really is.
definitely
Yeah.
for fun. Oh, we have another
Yeah. I
question
think.
here. Yeah, go
Oh,
for
go
it. Yeah.
ahead.
No, yeah,
Go
no, tell me
ahead. Yeah,
what
please.
you're gonna say about chat.
I think we focus a lot on chat. I think what I said earlier about it being suggestive, like
Mhm.
there's a human in the loop element to it. I think where applications are coming is where you can add suggestive capabilities to enhance um, our 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 productivity, our decision making. For an example for us that we're looking into right now is, chat is it's like a function of text to text input, text output. There's another one called embeddings, which everybody should be looking at. If you're using Lucene or Elasticsearch, you should be looking at embeddings right now because it's text input and a bunch of floats in output, like a big float vector. We have a couple minutes in the end, I can show that actually, but and you can use that to do classification sort of problems. And the third one that we find to be really interesting lately is two text inputs, a before and after, and the output is a number from 1 to 100 on how surprised the model is at the change. And that one's really interesting because we found that, like, when a recipe makes a really bad change, that it's called perplexity. It has a really high perplexity score, when just because it's like, I don't know, like, it's like if you're doing a code review and you, like, scroll past, you're like, I don't know, like, we
Uh-huh.
can't really say why it looks suspicious, but there's something that looks suspicious about this, and that's kind of what that one's doing. So I think, well, if I'm going to commit something to 1,000 repos, can we just not commit anything with a perplexity score over 80, and, like, maybe put those to the side and look at them a little more carefully? Um, those are the kinds of things where I think what is my alternative? I could run tests on everything, but that's a much more expensive operation. Is there a way I can use a model like that to give a real cheap indication that then, that I pass on to a more deterministic process? So it's a lot of hard to understand where all the applications are at this point. It sounds like we had another question coming.
Yeah, we do. And so I'll put the question up first, and then if you do want to, if you have the time to show us embedding. So another question from Ramaduna. If we want to upgrade plugins in our build.gradle or POM XML, should we configure each plugin separately and put them in a custom recipe and then apply it? Is there any other simple solution for it?
There's a couple things, so there's maybe two different interpretations of this question, so I'll answer both. For if you need to group recipes together, you can group them into a YAML file, kind of similar to what we saw earlier, where you just put a recipe list, and that then becomes, you can use that YAML file as an input to the build tool plugin to run multiple things over a given repository. If this question is about, I just want to update a particular repository without necessarily having to modify the build, in both the cases of Maven and Gradle plugins, you'll see in the docs there's a way of injecting with the rewrite plugin without actually modifying the project itself. For Gradle, that's done with what's called a Gradle init script. For Maven, that can be done with command line parameters, and so you can just kind of do it one-off and then move on to your next thing.
Cool. Yeah, so it's up to you, John. If you want to show embeddings a little bit or something else.
Yeah. I mean,
I'd love to see it.
It's a simple thing to show, and I think it's super interesting. We're actually using embeddings, or started using them for when we mess up. So we collect up a bunch of stack traces of things that we mess up because we're 300 million lines of code slot, and so imagine all those stack traces in a big spreadsheet, and how could I try to reason about the similarity of those stack traces to one another? Like how many different distinct problems do I really have when I see thousands and thousands of stack traces? And stack traces are just one type of text, and so that's that's the example here. This is actually a Jupyter notebook. So Jupyter is it's a data, big data sort of data science tool, where you can write little snippets of code to do different things, calculations and visualizations. And so I took in the spreadsheet of all the exceptions. And the interesting parts here, in this case, we're using OpenAI's embedding model, but there's open source ones as well. And so we're just adding another column using the stack trace as the input, and what we would get out is just a vector of floats. So just dropping another column onto the end of that spreadsheet, and then we do some other things here. There's a library that does what's called k-means clustering. So it tries to take all those float vectors and locate them. How close are they to one another? And nearness indicates maybe that it's actually the same problem. So physical nearness in space indicates that maybe it's the same problem. There's a way of using an algorithm called TSNE, which reduces that 5,000 dimensional vector space down to 2-dimensional vector space. And the point of that is to then be able to just display it. And so these are all the stack traces kind of roughly categorized into like, these probably are the same. This one's the same. This one's the same. And then, so now you imagine we've got a table, an Excel spreadsheet with a bunch of stack traces in one column, the embedding vector in another column, the cluster number now in another column of which color it is. And we want to take it and do one more thing, which is use a text completion, basically a chat-like thing, to say, what do the following errors have in common? I'm going to give you some examples and you tell me the theme.
Wow.
And so in this case, it said, I looked at all the stack traces and all the errors are caused by type mismatch between the expected type and the actual type.
Wow.
And that's what I mean around classification. Whether that description is right or not, it gives me something, to go on, and, allows me to quickly evaluate it using my own human reasoning, I think.
Wow. That's amazing. What were you
this
doing
has been fun.
Yeah.
What's that?
What were you doing before that? How were you approaching that before that?
I didn't really have much of a solution for it. I mean, Gradle Enterprise has a part of Gradle Enterprise is a parse failure analysis that uses, I imagine, some sort of similarity score, but a more deterministic one. So there have been other, attempts at this in different ways, but there's just, the other use of embeddings, and it's very similar to this one, is just think regular search, like product search. You've got a search box. And so you've got a bunch of things in a catalog and you just calculate an embedding for them. Now you type some text into a box, calculate an embedding for that. Now you're doing this nearness comparison. What is the thing that's nearest to the thing that I just put in the box? That's effectively what you're doing.
Right.
And that's simpler than taking like Lucene index and configuring more and more analyzers and tokenizers and things to try to strip, plurals off and name stemming and,
It also sounds like you're describing a recommendation engine.
Yeah.
Like
Recommendation, which is also very suggestive, right? So
Uh-huh.
recommendations is suggestive, search is suggestive, code authorship is suggestive. I think that's the main theme, is that these things are really good when they suggest something and a human makes a decision in the end as to whether to accept the output.
Wow. I mean, that's so powerful, because I feel like, sometimes I think that one of the greatest challenges of like the time that we're in is just the fact that there are so many choices and there's no way to make those choices. So if we could solve that problem for humanity,
just winnow it down.
Like here's a suggestion. There are 100 choices. Here's a suggestion.
Absolutely.
Which is,
it's just a larger thing of like, I want to do creative things. I don't want to do, life is short. I want to do creative things. I want to enjoy, use this really powerful brain of ours, and let's not do really repetitive things.
Yeah. As long as we always have to make it good values. Everything has to be rooted in good values.
Good. Yeah. With great power comes great responsibility. Yeah.
Exactly. Yeah. Well, I don't think we've got more questions coming in. But that was absolutely fascinating. And I really appreciate you joining us. I'm looking forward to the next talk, whether it's you or your new data scientist. Either way, we're looking forward to that chat. And thanks so much. This was really fantastic.
Thanks for being such an amazing host. Yep.
My pleasure. So before you go, I'm going to plug a couple of things here. I'm going to tell people, make sure I do this right. So please join our Spring Academy as our new website, where you can learn whether you're new to Spring or you're experienced in Spring. I think you'll find a lot of good information there, and it's all free. So please check that out. And in August, we are going to have our Spring One conference. It's going to be part of VMware Explore. So you get 2 for 1 if you join us for that conference. We look forward to seeing you in Las Vegas. And that's really it. So I'm going to close this out. Thanks again, John. And
thank you.
Thank you. All right. Where is here we go. All right. Okay. Bye, everybody. See you next Tuesday.